Good afternoon. My name is Michael Eriksen. I work for a company called Exact Consulting here in Denmark. And currently I spend a couple of days here helping the Java on Mainframe team with some experiences that I have from other stuff. So what I'm going to do now is to talk a bit about Java on the Mainframe in relation to the way that we are looking at doing it here. So I'll talk about why Java on set, what kind of language is Java, how it's implemented on set, how to develop mixed language applications on set, a small bit about security, and a single slide about education. So this is the second slot after lunch, so I suppose it's a graveyard shift. So I have a question for you. What do you think system exit, which is a Java instruction, does? Yeah?
It closes CICS.
Yeah, that was the next question. Because normally it would just stop your program, but quite true, what will it do in kicks? It will close down kicks. And those of us who have been running COBOL knows that if you use stop run in kicks, then it doesn't only stop your application, it stops kicks. So if you're using a system exit in a Java program inside kicks, this is what you will have. Of course, you will have 44 sets of undocked threads here, and then append 1800 and so on. So this is not very nice. So in theory, you can put in a Java security manager to prevent you from doing it, and I know that Dyneus is working very hard to make that happen. We still haven't figured it out yet, so until then, please do it. Not only will you shut down kicks, but you probably will be fetched by security and thrown out. So, I know that this is mostly a PL1 shop. I'm not a PL1 person, so most of my comparisons from Java to third generation languages will be to COBOL. And this is not a Java course. I'm certainly not qualified for that, but I'll give you some technical background on what Java on the mainframe is and can be. And otherwise, the presentation I did in October is available on SlideShare, and I think it's also available on your intranet. So a lot of the technical stuff about how the processor and the JVM has been developed to work better together is in that presentation. Right? So why do we run Java on set in the first place? And the arguments are different from different companies, but I think in general, it's to open the mainframe to a new generation of developers. And this question about portability of applications. And I've been trying to port applications from distributed platform to the mainframe, to Bash, and to kicks in Java. And generally, it works very well when you look at the functionality. You can take a Java application and move it, and you can run it on the other platform in most cases. What we have in Java is we have a very wide choice of open and closed source packages. And one area that some companies are looking at is the area of XML. Because we do have XML handling in COBOL and PL1, and it's very great for a lot of stuff. But I'm working with one customer in Sweden where they have a very complicated set of XML structures, of XML schemas in very many levels, all calling each other, and where you have variable levels with static levels, variable levels, and so on, which is very difficult to do the same stuff in COBOL, because in COBOL we have our fixed areas, sizes, and so on. So they have problems because these XSDs are made by an enterprise architecture team which knows nothing about mainframe and COBOL, but only about .NET. So in that case, they are looking at, could we use the Java XML handlers like Xerxes and Zaland and call them from COBOL instead of doing it COBOL, because the XML is too complicated. And I would say that the typical use I see out there is a non-mixed environment, an environment where you run COBOL here, PL1 here, and Java here. And what we're looking at in Danske Bank is to do a mixed environment development where we call COBOL, PL1 and Java from each other. And that gives some problems which I haven't seen many other places, but that's stuff we're working on. But in generally, what you see is that people are running Java applications, WebSphere and Bash and Kix and IMS, DB2 stored procedures, or in Linux, of course. Okay, as we all know, COBOL and PL1 are native to the mainframe. Show of hands, who is this? Yes, the mother of COBOL. Rear Admiral, I think. Yes, she was. She was working for the American. Yeah. There's nice pictures of her in uniform as well. But anyone knows who this is? He's called Duke, and he's the mascot of Java. And as I would say, Java is now also native to the mainframe, just born late. And when we're talking about old and new, then I would say that object orientation isn't something God-given. And if you look at what is old and what is new, then the actual fact is that the first OO language, Singular, which was invented in Oslo, Norway, it was formalized in the early 60s. And the last version of Singular was in '86, so it doesn't live anymore. The latest Java version is from 2014. COBOL was formalized 2 years earlier than Singular, and the latest standard is also 2014. So old and new, well. Once they asked the German Chancellor Kohl, if you remember him, aren't you a dinosaur? And then he looked at the reporter and said, well, I might be a dinosaur, but you should remember that before they became extinct, they lived for 165 million years. What's your life expectancy? What's your life expectancy? Right. Who else? I was put the question, who else are using Java on set? And I can't give you that answer. I'm not an IBMer. I don't have an official list of reference, and if IBM have, they're sitting very tight on it. But what I see out there is large-scale WebSphere users. It seems to take off for Kix users now, running in the JVM server version or the Liberty Profile version. And for historical reasons, all Croatian banks. And also, I was told a couple of days ago that Bankdata is using Jesus Batch. And the reason why all Croatian banks are using Java, they're using it in Kix actually, that is that a lot of the Eastern European countries, after the fall of the wall and the Iron Curtain, they started really at level 0 on much of the computing. Of course, we know that 120,000 users were using what was it, SAS software in Russia, even though they have never sold a single license. But in Croatia, they started when Yugoslavia had broken down, and they started on mainframes. IBM was doing a very eager job there, and a company down there called Vestigo did a lot of banking systems, which they're all using. So in Croatia, if you're using a teller machine taking out money, is running Java and Kix. So, what kind of language is Java? So, I like to compare it to COBOL. And if you take a COBOL program, and this is probably as small as a COBOL program you can get, it displays hello world and ends, and it doesn't stop running, it goes back. So, what we do is we have a compiler, we create an object. Tom has talked a lot about the compiler. So it creates an object from the source. And on the way it creates a pseudo-assembler listing. So this is the assembler code which the COBOL program is turned into, more or less, or a part of it. And you get an object which looks something like that, a binary thing, 80 bytes broad. And then you take the binder or the linker. Why ever did you change the name for the linker to the binder?
It's a different product than behind under the covers.
Oh, different product, that means new price. Okay.
I hate that there's now two binders.
Yeah.
DB2 binder and program management binder.
So there's a good reason to get confused here. But anyway, you take the program binder, which you used to call the linker, and bind the object into a program object. That's if you're running COBOL version 5, or a load module if you're running earlier versions. And this is what the load module looks like. Starts with the signature of the binder, IEWP or something there. And when you run the program, you have the loader, loads the program into storage, allocates the static storage, fixes up all the relocatable addresses, and passes over control it. Okay, we're all familiar and comfortable with this, right? We have seen it work. Java. What we have is a Java source. This is a much similar Java source. And Java is really not a compiled but an interpreted language, but more or less an interpreted language. So what happens is you compile your source into bytecode. There's no linking, there's no binding, and on runtime each class are loaded separately. So this is a symbolic representation of the bytecode of a program which we just saw, which looks interesting and strange, but if we want to look at it in binary, this is what it looks like. So this is what we are loading into storage when we are running a Java program. And each of these bytes, or 2 byte sets, is an instruction, like 47 blah 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 as a simple instruction. Right? So when we run it, we also have a loader. This is a Java class loader. And it does 3 steps. It loads the bytecode into the JVM, into the Java virtual machine. Then it does a link, which means that it verifies that the class is correct, otherwise it won't run. It prepares it by allocating the memory, the static memory it needs, and the stack and so on, the heap it needs, and it resolves symbolic references, much like we have seen. And then it does an initialization where it initializes values for the class variables. So it's different, but also much the same. So how is Java implemented on set? The JVM, the Java virtual machine, is a virtual machine which runs on top of our system. And what the JVM is really a set of C++ programs which together constitutes the runtime. As you can see, IEWPLM. So this is the it's on your PC, it's called Java Exit. This is the load module sitting in Unix system services on the mainframe, looking like this. When we want to connect between our 3rd generation languages and Java, the real way to do it is something called the Java native interface. And the Java native interface exists on all platforms, also on Linux and Windows and so on. And of course, it's how Java connects to what's below it. So the JNI would look different on a mainframe, like on a Windows, like on a Linux. But what it does is it enables Java code to call native applications, COBOL, PL1, assembler, and libraries, and to be called by them. And also it supplies a number of native functionalities which can help you convert arrays and strings and stuff like that between our 3rd generation languages and our Java programs. This is in general very complicated, but Brian Eisner has made a tool which should make this much easier for you. I'll have a shot at it in a moment. So this is what a COBOL JNI program looks like. This is valid COBOL, right? Just like you would write it, have been written it for 30 years, right? So the program ID is recursive. We have repository where we define classes, which is Java classes. We have an object reference, that's a pointer. We copy in JNI, which is the list of functionality, the copybooks. So we set address of JNI environment to the pointer. So here we get addressability to the Java. We set address of JNI native interface to another pointer. And then we can call, this is a function which can turn an input string into something Java understands. So we have input string mapped with palm string. So here we have COBOL and Java structures translated into each other. And then we invoke, this is a class name, this is a method name, and this is a parameter, and this is what's returning. So this is a full COBOL program which initializes the Java virtual machine, some 20 million instructions or something like that, and then calls a class. And this is a Java program which is called, very small, it's get called with parameter input string, print something out and return 4711. Anyone knows what 4711 is? That's a perfume, yes. Okay. When we want to call DB2 from Java, we can use a static version called SQLJ, which looks much like the SQL we're coding in PL1 and COBOL, or we can use JDBC, Java Database Connection, which is dynamic Java. And I'm not going into the details because what you do is it's the same thing that you would do dynamic SQL in your classic programs. But I just wanted to show you that when you look into the file structure on the mainframe, then we have all these jar files, Java archives, and zip files, which is the JDBC interface. But all these things that you can find in the structure on your mainframe, all that is really symbolic links, because what we really have is we have these six load modules. Traditional load modules, except that all these load modules have a number of different entry points. It's like dynamic link libraries, DLLs, if you know those. So what we have is something which looks Java-like when you look from the above, and which looks traditionally load module-like when you look from below. Okay? So, which runtimes can you run Java on the mainframe? Any suggestions? Very simple. All of them. There's probably nowhere on the mainframe you cannot run Java. You can run them in batch. We have 4 different kinds of batch. I'll get back to that. We have 2 different ways of running it inside Kix. The JVM server is the more traditional way to do it. With Liberty really means that we have taken a WebSphere application server, slimmed down, and put it into Kix. It's not the same not the complete WebSphere as you are running natively on your system, but it's a scaled down, it's a Liberty profile with functionalities like PHP, mobile JSON services, servlets, Java server pages, SAML security, and you can run JDBC type 4 if you should want to. So a lot of stuff which you would perhaps like to run, which you can run on WebSphere or on a web application server and would like to run it inside Kix, you can run this unchanged on the Liberty server inside Kix. But if you're writing more traditional stuff, you would use the JVM server part. On DB2, of course, you can connect to DB2 with SQLJ and JDBC, and you can write stored procedures in DB2. IMS has Java messaging programs, and it has JDBC calls to the IMS databases. MQ has got an IBM WebSphere MQ API, and it's got the native Java JMS interface. WebSphere, Classic or Liberty, and set Linux. So really, it should you can run it everywhere. So, as some of you might remember from my other presentation, over 20 years IBM have been optimizing the processors to run Java virtual machines, put more and more functionality into it to make the Java perform well, and they have optimized the IBM JVM for the processor. And of course, you should be at the highest level of both Z13 boxes and Java 8. I don't know, is Java 8 available now on mainframe? Yes, it is. So you should do that, because then you take advantage of all the instructions that Henrik and Tom has been talking about. And if you look at it, then in theory, performance should be comparable between Java and COBOL. And I have been over time writing small Java programs in Kix which performs equal to COBOL, but of course things might be very different. What would you say? Your mileage may vary. So if you put on the yes cap, then in theory performance is comparable. But of course, in theory there's no difference between theory and practice, but in practice there is. And, as somebody said, theory is when you understand everything and nothing works. Practice is everything works and nobody knows why. And here we unite theory and practice because nothing works and nobody understands why. That is not a declaration of the state of the Java or Mainframe project, because we actually understand a lot and we've got a lot of things working, but we still got a lot of challenges. Is that true? That's true. So we have a number of issues on the mainframe, like virtualization conflicts, the CPU usage when you load and initialize the JVM, garbage collection policies, heap tuning, heap size tuning, and also the question, I think I pulled the last one out when I thought I had short time that I had. You can find that one in my old presentation about how the implementation has evolved in IBM. Interesting history, but not so important for now. So, virtualization. Anybody here knows about virtual storage? I think so. Most of us have known about it for about 40 years or something like that. Anybody here knows about virtual machines? Also, we've known about that for about 40 years. Java has its own virtual machine, the JVM. And while the virtual machines that we are running on the mainframe, they're used, you know, when I grew up, it was, we had an apartment in a 5-story building with apartments and so on all around the block. And if somebody made noise, everybody could hear it. And if you made love in the summertime, you should certainly close your windows and so on. But so the mainframe has been brought up. The JVM, the virtual machines and mainframe has been brought up in a multi-tenant system and adhering to traffic rules. Java is a spoiled brat. Java has no manners. It grabs all the storage it can. It makes no assumption that there's anybody else living in this building. So that has been the main challenge of IBM, to try to educate this spoiled brat to behave so the rest of us can also be in the same building. It has been handled in different ways on ZOS, especially in Kix, where they've been doing a lot of experiments over the time. When they started doing Java and Kix, and that must have been about 1998 or something like that, they told us that to run a COBOL program you might use 20,000 instructions, but to load a JVM, just to load it in, you need 20 million instructions. So what they have been doing is finding ways to keep the JVM running, to sharing it, and they've been doing that in 6 or 7 different ways over the years, while they have been experimenting and trying out to find how to do it most efficiently. And I think that they're about there now. So now you have a JVM server with a number, I think up to 256 JVMs running inside that server, and they're initialized together, and they're sharing storage and sharing classes and a lot of things. So that means that when you start the Kix with the JVM servers, it takes some time, a minute more perhaps or something like that, but then everything is ready to run. So that's a good way of disciplining this brat. But of course, if you have a situation where you're running a Java virtual machine, running in virtual storage on top of ZOS, perhaps running that on top of ZVM, running on top of Prism, then there are bound to be some conflicts and some things that your performance department will have to look at when your usage of Java grows. Can we say exactly where that will be and how? No, we'll have to measure it. So when you load and initialize a JVM, it can take a lot of MIPS. I've been involved with a project running WebSphere application server in a 2 LPAR situation, and when they took it up, there's not a number of versions ago, but they were doing it in production. But whenever they recycled the WebSphere with 11 address spaces, each of them with a lot of JVMs, it took 300 MIPS in 15 minutes to recycle WebSphere. That's not something you want to do at 11:30 in the morning. So it's important to find out how to minimize the loads of JVMs and how to reuse JVMs. One thing which you should look at, of course, is something called the shared class cache. And what that is that if you put a switch on your JVM which has /x shared classes, then it creates a cache which is common for batch and for kicks. And the first JVM, which starts up with this parameter, loads what it needs into the shared class cache. The next one reuses what's already in there and adds whatever it needs. So that means the first one will probably take more time, but not more time than now, because it's still loading it in, but now it will be loading it into a class cache. So that means that a lot of that stuff will be loading in there and will be staying there probably until your next IPO. There's a number of considerations to take, of course, if you want to change classes which are in there and stuff like that. But this is probably something which will be important if you're running a lot of similar stuff across your LPAR. Right? Inside Kix, they have a similar functionality which is called the middleware bundles. And if you read the manual for Kix, it says that stuff like MQ and DB2 classes, OSGI bundles, that's just a way of packaging Java classes, Java programs, when you deploy them in Kix. They say that DB2 and MQ you should put there, but actually if you have other stuff which is shared or which needs a lot of load, then you could put it there. I've been working with a project where we had a lot of classes which were shared, which took a lot of time when we want to deploy them, when we just deployed our application. So we were recommended to put those into OSGI bundles. They are loaded into the system when the JVM is started, and then it sits there. So that's probably an important thing to do when you run Java and Kix. The scope of this bundle is the single JVM, and you can have various JVMs inside the same Kix. So there's a lot of mapping you need to do to find out who goes with who. One thing that you will experience as a developer, when you are trying to develop applications which run between third generation language and Java, is a difference in storage. Because storage is static in COBOL and assembler in PL1, and storage is dynamic in Java. So you should not call from Java to COBOL with an area that has not yet been allocated by Java. At one time, at the earliest implementation by IBM of EGL, of web services in Kix, actually we could see that different teams had been developing different parts of the EGL compiler at that point in time, because when we started running web services from EGL in Kix, then it started doing something in Java, which sent an area across to COBOL, but the area wasn't allocated, but COBOL thought it was allocated. So we had some very interesting experiences until that was fixed. And you can probably run into the same kind of problems if you're running from Java to PLA to COBOL. And I won't read this for you, you can read it afterward, but in general, in COBOL, if you declare something, it's being allocated. And it's been taken from the language environment, stack storage, and heap storage. You can read that later. And when you're doing storage allocation in Java, some things are allocated at the start, but for the JVM as such, whenever you start a JVM, it allocates the entire heap from the maximum heap size parameter that you're given when you initialize the JVM. So all this storage is loaded once and into contiguous storage. into your address space. So you have to allocate for the maximum heap size, and you have to look at what is actually the optimum heap size to use. Because you can also do memory allocation functions by Java, but you shouldn't. The JVM can do it, or other JNI programs can do some of the same stuff. They would allocate in the same LE heap as well. So they are competing about the same space, but they are doing it different ways. There are things you should be aware of when you get your hands dirty here. When you allocate data in a third generation language program, you allocate it by declaring it, and when you start the program, it's allocated. In Java, you allocate it as you go along, and you deallocate it by using a function called garbage collection, which is you can call garbage collection yourself, but normally you won't. So every now and then the system says, now we have put too many objects into the heap, you have to clean it up. So it does garbage collection. What it does is that it marks all your active objects. So it goes through all the objects you have in your system and says active, 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 doesn't know about this. And then they delete, then they compact storage. So they take, some of you might know storage compression from Kix. So they take all the active objects, move them somewhere else, and whatever is left is getting deleted. And in the original version, they just had one pool to do it, one area to do it. That gave performance problems because they found out that 90% of objects are deleted again like this. So they have a nursery, or whatever they called it, a part of the heap, and then they have a more permanent part of the heap. So they're first garbage collecting the initial part, and then they're garbage collecting the other parts. And there are different pools, and there are different policies to do it, because if you have a very big heap, then you can wait a long time before you have garbage collection, but then when it does, it does a lot of work and you have to wait while it does it. So we have questions for performance like pause time and pause predictability. And the predictability question, of course, is important because we used to say in Kix that if you have a response time less than 2.5 seconds, that's okay. After 2.5 seconds, your brain starts moving somewhere different. But if your response time is irregular, now it's 1 second, now it's 1 second, now it's 5 seconds, and so on, people get completely desperate. So you have to take care of having predictable response time. That means you have to look at making your garbage collection pauses. Yep.
5 minutter. Tror du, er det ikke krav?
Nej.
Nå.
25.
Nå.
Garbage collection.
Was the garbage collection starting?
Garbage collection called CPU, and you have to look at your memory footprint as well. So, and you also have, if you code errors in your Java program, you'll have memory leaks where you can't get rid of objects even though they're dead. So, they have 4 different policies, and that's a definition you set on the JVM when you start the JVM. When you run inside Kix, you normally use generational concurrent garbage collection, which is good for high transactional workloads. But if you have application with responsiveness criteria, you might use optimum average pause, or for bash you might use this. You have to experiment with which gives you the best performance in your large applications. Normally in Kix and many other places, GenCon is the optimal to do, but if you have performance problems or your garbage collection doesn't work as you want to, you might have problems there. I was talking about the heap, and what happens if your heap is small, then it gets filled up quickly, and you have garbage collections very often. If it's very big, then each garbage collection takes a lot of time, and they talk about stop the world. And that's not a joke. So what you need is tools, measurement, statistics, and tuning. We cannot know before we have seen your applications running, how they will perform and how we'll need to tune them. But we have to tune them also on 2 levels because Java heaps, as I said, lives on top of language environment heaps, and you can tune and measure the language environment heaps, and you can tune and measure the JVM heaps, and you have to look for paging and swapping as well. Or, as they said, you can just go to IBM and buy more storage. What you have is something called the IBM Support Assistant. And what you probably can't see here is there's a long list of tools, of different tools, both for Java and for other stuff, which you can instantiate. So here we have instantiated the health center and asked it to run. It starts with a summary. And then it has one set of graphs for CPU usage. Looks like this. Another one for garbage collection. This is a very small system with just a few transactions running. But as you can see, it shows you pause time and whatever happens. So this stuff can give you an insight when you're starting writing your Java programs to see what is going on inside it. This is a graph for file I/O, mostly for class loading. This is a profiler which can find out how much time is used in the different parts of the application and the different classes, so you can pinpoint where your performance problems might be. And there's also a thread analysis which found out which threads are running, the number of threads, and so on. And there's a lot of stuff and a lot of parameters and a lot of graphs, and we really just have started to look into them and find out what is useful, what can we do. But the point is, we do have the tools. So, for development, you can use any Java tool like Eclipse. If you use RDZ, then you have support for special APIs like JKicks and for OSGI, which is a way of deploying Java classes into kicks. And if you have coded Java or have programs which have run on other JVMs from Sun Oracle or from other vendors, you will find there's no difference. From the development side, from the application side, there's no difference, only from the other. So, when we are going into mixed language development, there's features, as I said, in Enterprise COBOL. So, we looked at the program earlier, which looks something like that when you call it from COBOL. One thing you should be aware of is addressing modes, because COBOL runs in 31-bit mode, and Java can run in 31 or 64-bit mode. So if you have Java programs running in 64-bit mode, calling COBOL programs or PL1 programs in 31-bit, you might get interesting results. So when you're running mixed language applications, you need to be running them in 31-bit. When you're running Java in batch, you have 4 ways of doing it. And these are all Unix system service stuff. So if you just run a batch program in Unix system services, you use something called BPX batch, which is a batch launcher. It runs a batch programs like you could run TSO batch, ISPF batch, and so on. It's very limited. Then there is an open source extension to it called COZ, which can do a bit more but still is limited. Then there is the JSOS, Java on ZOS, which is a Java batch launcher, which can be used for Java. And then there's finally the batch container, which is a managed environment for Java, as they say, and it allows COBOL and PL1 and Java programs to interoperate and to do it with DB2. So the last one is the one that we are looking at here. The one here, as I said, it's got a lot of limitations. I won't go through them here. And some of them are lifted if you're using the version called, not called BPX batch, but BPX batch SL. And if you're using COZ, then you have a bit more functionality. But it's very limited, and you can use it for running Java programs, but not for mixed programs, I think. JSOS gives us a lot of more functionality. So what it is really it's a Java program which then launches other Java programs. And it runs in the same address space, whereas if you're running the earlier one, it runs in different address spaces. So it makes it easier to account it and easier to integrate in your scheduling environment. And the final one, which is called BCD, ZOS Batch Runtime, it is, as they say, a Java-focused platform-neutral programming model. So what you have here is you start up a very big Java environment, which then can call your Java programs, your PL1 programs, your COBOL program, and can keep them within one transactional scope with DB2. This needs that you have resource recovery service running, managing it, and there's, of course, a number of overhead issues involved with that. This is the slowest and the one with the largest overhead, but also the one with the largest functionality. It's also consistent if you're running any WebSphere-based batch, and as I say, it must run in 31-bit mode. If you try to run it in 64-bit mode, you'll crash heavily. Then, as one of my last points, I'll just show you what debugging can look like. So I've taken a program, an application, which is a COBOL program calling a Java program running inside Kix. So the first we need to do, we need to understand that we're using two different debuggers. So what I'm doing first is I'm setting up the debug tool in the first point, then I'm setting up the Java debugging, and then I can run my transaction. And what this looks like in the debugger is, I start here, debug tool, starting my COBOL program. At some point in time, it does an execute link to a Java program. So here it jumps to the Java program. This is a Java Kix program. Just continues here. And whenever this is finished, it returns back to the COBOL program. So what we have here is we have a seamless debugging, but it takes some effort to set up the debugging before you start, because we are starting two debuggers. We haven't found yet, at least, a more elegant way of putting it together. I hope we can. So security. Java security in RAGF is based on something called EJB role. And the name is from the time when all Java was EJB and on the mainframe, and they have kept the name. So any kind of Java RAGF security is put in the classes under EJB role. And there's a lot of profiles under it. You can do a very fine-grained security definition on that. And these are just examples of roles, and you can call this call line role, this user role, and so on. This is used heavily by WebSphere, and you can use it if you're running Kix Liberty, if you're running batch Java as well. If you're running Kix JVM server, then you have the normal Kix RAGF security. And then also, as I said in the beginning, you have the security manager, which we hope to be able to forbid system exit and other dirty things. Right, the last slide. Education, what do I need? And I say, if you are a traditional PL1 or COBOL programmer to whom this is all new, there's different things to learn. And one thing is to understand object orientation, and for me, I would say that understanding object orientation was a cultural revolution, like the first time I understood virtual storage and the first time I understood what a transaction system was. So it was really a big leap to understand that object orientation, yes, on one hand, it's a better way to package variables, but on the other hand, it's also another way to package application and do things differently. And some object-oriented languages like Smalltalk are very, very clean and nice. And when you look into Java, you'll find it's really some kind of hybrid, because Java is really somewhere between object orientation and search generation. And I know that some of the people at Sun, when they invented it, you know, they have C and C++. Some of them call this called Java for small talk minus minus. But there are stuff like inheritance, encapsulation, and polymorphism, and I want to explain them to you. That's a course for itself, which you have to understand to code this properly. A lot of Java code is really procedural code with Java classes. If you want to code real Java, real object-oriented, you should understand this. Then of course there's the syntax and semantics of language. Also, the language, Java, is rather a small language. Most of what's happening is happening through libraries. Some of them with the language, some of them by IBM, and some of them picked down by open source. And one problem they have in many installations they are running Java is that whenever a Java programmer runs into a problem, they might decide just to go looking with Google to find, somebody had a class, I put that into my application. Somebody had a class, I put into my application. And then you might end in a situation where quality assurance is a city in Russia. You have to understand your development tools, your Eclipse, your different mapping tools, and other tools connected with your environment where you're going to develop mixed language applications. You need to look at your performance tools. I know performance is really the job of operations, but application developers should also understand the performance issues of what they're doing. It's better to fix it while you're developing than when it's running in production. There's your site and specific knowledge, of course, as well. So I would say that there's a bit of learning to do if you want to be a really good developer in this area. So that is about what I had to talk about. Any questions?